Hello world, and welcome to this edition of Tech on Fire with Blaze. Today we're going to be talking about what is a single page application, and we're going to be looking at how these actually work. Before we can talk about a single page application, I thought it'd be appropriate to define it, so I swiped a definition from everybody's favorite reliable source, Wikipedia. And Wikipedia defines a single page application as a single page application is a web application or site that interacts with the user by dynamically rewriting the current page rather than loading an entire page from the server. So to animate this, I thought it'd be appropriate to show you what this looks like with a interactive graphic, if you will. And this basic animation kind of illustrates the point of what a single page application is versus a traditional web app. So in a traditional web app or website, what happens is the browser on the left in the client, represented here by this laptop icon, will make a request, say get web page, and then it will send that request over to the server, and then the server on the right here will receive that request, and then it will render a page on the server, essentially the HTML and as one contiguous file, and then send that back over to the client, and the client, which is the browser, will then render that web page in the context of that browser. And it'll repeat this process every time a new page is loaded. So if you click on a link, it makes another GET request, and then it will then go to the server, get that new page, and then bring it back to the client and re-render it. And this method of getting pages and returning them is how traditionally the web was started, and it's still widely used today by most or many popular websites. A single page application is slightly different from this in that it will first do the get web page and go get that from the server, but it differs in one respect, that once it's got the page loaded, instead of going out and getting a new web page with every request, it will issue a command, say get data, and it will issue that back to the server. And the get data then will return back to the client data in the form of some kind of file such as JSON or XML that is not a full web page, it's just a snippet of data, and then that gets sent back to the client rather than an entire page. And then the client will then take that data and change some portion of the web page that it is currently looking at. And rather than reload the page with every request, it sends back a request to the server and gets more data, and that process is repeated over and over. And so you end up with a single page making requests back to the server rather than reloading multiple pages, and that's where it gets its name from. So this model of application development has really created a different kind of approach to building applications on the web. And the traditional model still is very alive and well, and single page applications is just another way of doing applications that are web oriented. And like everything, it comes with its own set of advantages and disadvantages. Now, single page applications were trying to answer the question of how can I make more interactive websites? And then there were some other advantages to this as well. Some of the other advantages is that single page applications are easily scalable in that when you offload the rendering of a page to the client, you are taking advantage of all of the compute resources on a client. So rather than render every page on the server, you don't have to spend CPU cycles and memory and RAM doing that for every request. You simply just send a single page back to the client, and then let that client render it with its own resources. So it makes the application easily scalable across the clients rather than doing that all work on the server. Second, it can be easily distributed through a CDN. Now, a CDN is a content delivery network, so it allows you to take your application and distribute that globally by keeping copies on a content delivery network so that the actual application is geographically located close to the actual client that's going to be using that application. Thirdly, it can be more easily taken offline or converted into a progressive web app. So there is a way of using web-based technologies, particularly with HTML5 and JavaScript, which are the primary technologies behind most websites nowadays, that allows you to take them offline and create a so-called hybrid application. And these are essentially single-page applications where they are installed on the local computer of the actual client that's going to be running that. And rather than getting the application from a server and loading that into a browser, it loads up essentially a browser shell, and then will allow that application to be loaded off the local hard drive, and that way it can be kept offline and doesn't need a internet connection to actually be able to do things such as enter data or interact with data on the local machine. And the idea of a progressive web app is similar to hybrid, but what this does is allows you to encapsulate a application into a progressive web app that allows you to install that locally and have that run inside of a browser, but it's a little bit different than a hybrid app where it's not installing a full browser to run that application. In fact, it still runs in a browser. It installs locally within the context of that browser and allows you to build an offline application that way as well. And fourthly, it can reduce the amount of bandwidth that is used by an application. Now, when you have an application that has a lot of data and you're going back and forth over the wire, and say you're doing that with a traditional web app, the actual number of requests that go back and forth over the wire when you have an entire page that's being rendered can be rather heavy. But if you're just requesting a snippet of data, it can reduce the amount of bandwidth that's actually used by your application. Now, there are some disadvantages to this. It makes the client side more complex, so you have to have a complex client in order to take advantage of this. And there's several frameworks out there that attempt to tackle this complexity, such as Angular or React, and there's other ones out there. And these frameworks are designed to help build a common framework for building single-page applications that can be used in the context of a browser or in the context of progressive web apps or hybrid apps. Secondly, the support for older browsers can be an issue. So a page that's just pure HTML, CSS, and JavaScript, and maybe some images that's not complex can typically be loaded in older browsers more easily. However, a single-page application might struggle to run in older browsers, and this has always been one of the challenges for using single-page applications. Now, it might not be an issue for some organizations that want to distribute these applications internally, and they can control what browsers the people that are going to be using the application have, and they can just use this application in Firefox and Chrome and don't use it in IE8 and it will run fine. But for public-facing applications that are single-page applications, you don't have the ability to tell a user what browser he or she can run on his or her laptop, and they might be running an old version of IE or an older version of Chrome or even Firefox that doesn't render the application, and that can be a challenge for single-page applications. Thirdly, they don't always work well on mobile devices or devices with limited resources, and the reason why is because these are heavier applications that have a lot of JavaScript and typically require more processing power and more RAM than just a basic web page would, and mobile devices and things like Chromebooks are resource constrained in terms of RAM and CPU because they want to save battery life rather than have a really powerful laptop and a lot of RAM. They opt to have less powerful components in favor of long life on the battery. So these kinds of constraints make it hard to run these kind of applications on mobile devices and Chromebooks and the like. However, that doesn't mean they can't be run on these. It just means they might be a little slow. And fourthly, the initial load time for these applications can be high. And this is typically because they have a lot more JavaScript and CSS and other type frameworks that have to be initially rendered in order to get that initial page up and running. And typically, once you get the actual page loaded, it has to do an initial request for data as well. So there's actually request for the actual web page, and then after the page loads, it goes out and gets the request for the original data, and then pulls that back and then renders that on the page. So the initial load times for these are typically longer than what you would have in a traditional web page, where it all comes back as a single request or a couple of requests, rather than using JavaScript to do that. So the next question is, when should I use a single page app, or when should I use a traditional app? And this is not always clear, but here's some guidelines that you could use to help guide the decision to choose between one or the other. A single page app works well when you need interactive or rich content. So your application is primarily going to be focused on editing something. Say you're editing a blog post, or you're going to be editing photos, or you're going to be doing something where the user is going to be doing something on that particular app with the client, and it needs to make a lot of requests back and forth to the server, and you need to keep it in the context of the browser. This is where a single page application is really going to shine. It's also good for complex apps. So complex apps would be things that have a lot of various screens that interact with one another in subtle ways. So rather than having to re-render each one of those screens with every request going back and forth to the server like you would with a traditional app, you can do that on the client side, and they can communicate in a local context with one another. So this makes the user experience much better and much faster than having to reload that page with every request or every change. It's also good for apps that don't need large data sets. By that, I'm talking about large client-side data sets, not server-side data sets. So a large data set in a local context in a browser is really not a good idea, because browsers really aren't designed to handle large data sets. They're designed to render HTML, CSS, and execute JavaScript, and they are typically very heavy in terms of memory usage. Imagine if you try to load all that kind of data back to the client side by way of JavaScript objects. That means that it would bloat the page and maybe even crash the actual site that you're using, or the browser. So the idea here is to try to keep the data to a minimal, what's going on inside of a single page app. And there's also the issue of moving all that data across a wire back to a single page application as well. And so a single page application is not really conducive for that. However, that doesn't mean it can't interact with large data sets by way of requests back to a server. Now, you can do that with a single page application. And this is also very useful for what I might call hyperscale apps. Hyperscale apps are applications that are intended to be distributed widely with hundreds of thousands or millions, maybe even billions of users. And a hyperscale application is one that you want to distribute across a number of servers that are globally distributed, and you want to be able to deliver that application close to the actual user by way of something like a CDN. Then a single page application works well for that, because these are easily packaged and sent to a CDN, because they don't really need to have the server involved to actually render the application. You can send down more or less static files to the actual browser, and then they make requests back to some kind of APIs through JavaScript, like we've mentioned already. And a few examples of this would be applications like Gmail, Office 365, or Draw.io, which is one of my favorite apps for drawing diagrams. Now, some traditional app use cases would be things like apps that focus on content consumption rather than content interaction. So this would be things like blogs, news sites, and wikis. So with these kinds of websites, you're going there to read about or consume information with very little interaction with that site. So you're just basically scrolling through it, reading an article or reading a recipe or reading about something, rather than actually interacting with that content or creating new content or editing that content. Traditional web apps also lend themselves to apps that don't need as much interaction. So this might be something like a photo gallery or a search site. Now, in these applications, I am not actually editing the photos. I'm just looking at the photos. I'm not really doing much with them. I'm just kind of viewing them as I scroll through them. I might click on one and it take me to another page that gives me a larger version of that image. And this is typically how a lot of sites, like where I get a lot of my stock photography from, Pixabay, work, or something like a Google search page where you can type in a search query and it gives you a list of websites that you can query as well. So these are all examples of applications that don't need much interaction. For apps that don't need a large data sets on the client side, that's where a single page app shines. But in a app where you need to interact with large data sets and you need to crunch on those and then render some kind of view back to the user, this might be where a traditional web app might be more handy, because it can get you much closer to that data set and then interact with it on the server side. So we're talking large sets of data that you load back to a server that processes that to generate a page to send back to the user. This might be like a report or something like that. And a traditional web app, it works well for those kinds of use cases. And some examples of these traditional web apps would be things like Wikipedia, Google's homepage, or most WordPress sites. And Wikipedia is basically reading an encyclopedia article. Google, I'm doing a search, very little interaction there. And then WordPress sites, I'm basically reading somebody's blog about, or I'm looking up some information and that posted that through a WordPress site. So these kinds of use cases will kind of help you delineate when should I use a single page app and when should I use your traditional app. It's not always cut and dry as it might seem, but in most cases, it's going to boil down to how rich is the content, how much interaction am I dealing with versus how little interaction I might have, or am I primarily focused on consumption of data versus interaction with data. Now, for my little serverless blog project that I've been working on, I do have this architecture here, and notice up on the top here I have my admin site, and this is going to be statically hosted on blob storage. Now, my admin site I'm designing as a single page application because it's more interactive in that it's going to be dealing with the editing of content and uploading of content to blob storage through an application. But what it's actually going to be producing is what is more of a traditional web app, which are static pages and posts that are going to be my blog posts and my pages that are going to be on the pages that are created by this website. So my actual product of my serverless blog here is going to be a traditional web app, while the actual portal that I'm going to be using to create this is going to be a single page app. So in this little project, I'm actually going to have both traditional and single page applications represented. I'm here in Visual Studio Code, and Visual Studio Code is where I've been editing my APIs. As we looked at last time, we looked at how you can create HTTP triggers with Azure functions, and these functions are then interacting with blob storage and table storage for data as it relates to my website. Now, I'm going to go ahead and start debugging these, and this will start these in the console down here. And once this starts up, that means my APIs are running. I'm not actually running these in Azure. I'm running these locally Azure right now because I'm still developing them. And now that I have these running, I can come down here and load up my single page application. Now, notice I'm not loading this off a web page. This is actually a locally hosted page. It's on my local box here. So I'm not actually pulling this back from a server. And this is one of those use cases I was talking about earlier, where you can have a application taken offline and then have it interact with a server without having to do multiple requests back to that server every time you want to reload the page. So I'm actually going to load this off the local file system into Google Chrome. Now, Google Chrome then is going to render this page and load up some data. Now, notice that there was a little bit of lag between when the actual page loaded and when it actually got the data. And that's that initial load time I was talking about, because it had to get the page loaded into memory and then go actually make a request in the background to get the data that you see here. So currently, there's not a lot working on this. I just have this first page going out there, getting some data, and then rendering that data by way of JavaScript. And then if I click on the edit button, it takes me to this page here, which is actually going out and doing another request to get the actual content that I'm loading into this rich text editor. And notice that the single page application is more content rich than is a developer. Is more content rich than a typical web page I'd be using for consumption of the blog that I'm actually generating with this. So I'm actually interacting with this inside the context of a browser. And then once I have this done, I'll be able to save post, and it'll post that back to the server by way of the APIs. Now, to show you what this looks like behind the scenes, I can open up the debug tools inside of Chrome. And let's go ahead and minimize this guy down a little bit so we can kind of see what's going on with the page right here. And right here, I'm going to open up the network tab so we can see what's happening on the network as this thing loads. So if I hit reload, reload the page, it loaded the document locally, and notice it went out and it went and downloaded some resources that I have defined here, JavaScript files, jQuery files, and CSS that are hosted on CDNs that I'm actually getting that content from. And that's my initial load there. And then once it got the quill.js, which is that rich text editor that I had there, once I got that, it did an XHR post. And this is where it actually went out and did a request for data. And it went out there and downloaded these posts right here, which are just a array of objects that it got passed back to me by way of a JSON file or JavaScript file that then took this right here and loaded it into this table right here. And notice if I hit edit, it's going to do another post against this API here. It's going to pull back another object that is just the post that I care about, but this time it actually has content in it that is the actual HTML that I'm interacting with here. And then the JavaScript then populates these forms right here, and then I can interact with it. So every time I go out there and do a new request, I'm not actually reloading this page. No, I'm not getting any of these other files. I'm just getting back new data and rendering that back to this form here. And so I can do that for every one of my pages. And this allows me to have an interactive web page without actually having to reload it every time from the browser. So this is a very basic demo of this single page application concept, but it does give you the idea of what I'm actually doing under the hood with a browser and interacting with some APIs and getting data back from that API and then interacting with that in the context of a browser. So thanks for watching this edition of Tech on Fire with Blaze. Next time we're going to look at more in detail about what goes on inside of Azure functions as we put these back onto Azure. I'm going to show you how to create an Azure function on Azure and then pull in some of my functions here and then be able to call those from my single page application. So thanks for watching this edition of Tech on Fire with Blaze. If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.